The purpose of this experiment is to understand the relationship between torsion, angle of twist, and the span and shear modulus. If you refer to the manual, you will see a relationship between angle of twist theta, the torsion T, the span L, shear modulus, and the polar moment of inertia. So we are going to use this setup to understand that relationship. What you see here is a rod clamped at two ends, and we are going to subject this rod to known torsion, which is applied by the load at a distance of 10 centimeters from the center of the rod. So this load would subject this rod to some torsion. The angle of twist is measured using the displacement at a distance of about 5.7 centimeters from the center of the rod. So the angle is nothing but the displacement divided by the distance at which it is measured. And we can record the displacements for different values of load, and we know the properties of the bar, the dimensions of the bar. So you could derive the value of shear modulus using the expression relating all of these quantities, and you could compare that shear modulus with the nominal values that you would find in textbooks. We are also going to look at the relationship for different lengths of the rods or different spans of the rod, starting from 6 centimeters, that's the total length of the member, and the apparatus takes up 3 centimeters at both ends, so the span for this member is 0. And there are different lengths ranging from 6 centimeters all the way up to 54 centimeters for the length of the rod, which means the span is that number minus 6 centimeters. And you will record the applied loads and displacements and study the relationship between torque, twisting angle, and span.
This is experiment number 8, twisting test. This is the experiment setup. Weights weighing 100, 400, 500, and 900 grams. Aluminum rod specimens that are 6, 24, 34, 44, and 54 centimeters in length, steel ruler, load tray, and displacement transducer. The displacement transducer must be set vertical to the ground. Install the 54 centimeter rod onto the test apparatus. Tighten the screws on the test apparatus, both on the top and below. While tightening the last screw, make sure that the lever is horizontal. Set the displacement transducer vertical of the lever and into the slot. Set the load tray onto the test apparatus. Once it stops moving, set the displacement transducer to 0. The distance between these 2 points is the span length. Slowly remove the load tray and add a 500-gram weight to it. Then hang the weight tray again on the test apparatus. Note the readings on the displacement transducer. Remove the load tray again and add weight till the total weight is 1,000 grams. Hang the weight tray and note the readings on the displacement transducer. Remove the load tray again and add weight till the total weight is 1,500 grams. Hang the weight tray and note the readings on the displacement transducer. Then remove the load tray. Remove the 54 cm specimen rod and replace it with the 6 cm rod. Tighten the screws. Make sure the lever is level, then tighten the screws vertical to the lever and place it in the slot. Then hang the load tray on the test apparatus and set the displacement transducer to 0. Remove the load tray and add 500 grams weight to it. Hang the load tray back. Then note the readings on the displacement transducer. Repeat the same process with 1000 grams and 1500 grams. Next, unscrew the screws on the test apparatus and remove the 6 cm rod. Repeat the same process using 24, 34, and 44 cm rods. Note the data on the displacement transducer. When finished, unscrew all the screws and unload all the weights.